right. Hi, my name's Peter Trappa, and I'm Dean of the College of Science here at the University of Utah. And I want to welcome all of you to the second installment of Understanding the Science, a partnership between the College of Science and Intuitive Funding. Understanding the Science is our way of bringing to you what research and science show about issues that are facing us in our everyday lives here in Utah, together with valuable input from government and community leaders. The COVID-19 pandemic, more than anything, has highlighted just how important science is in our lives, and we at the university are committed to providing factual, evidence-based answers to address the issues that we face as Utahns. This evening, we'll be discussing the COVID-19 vaccines, including how they were developed, how they're being rolled out, and how they will help us move forward from the global pandemic. A big thank you to a friend of the College of Science, Intuitive Funding, for making tonight's webinar possible. And again, thank you all for joining this evening. I look forward to seeing you at future events. I'm going to turn things over now to the moderator for tonight's event, friend and neighbor Tom Thatcher, who will introduce this evening's fantastic panelists.
Thank you, Dean. Appreciate that. And welcome everybody to our second event on COVID-19. We're so excited that you can be with us tonight. I would like to kind of go over some of our ground rules. First of all, our objective in understanding the science is to give the public correct information. There's a lot of hearsay. You hear things from your friends, from the newspaper, from the news media. And the objective of this webinar is to try to give you the science and the best factual information we can give you from the experts who know it. Also in this webinar, we're going to make every effort to get through all of the previously submitted questions. So panelists, I'm going to try to keep things moving, but I also want to make sure that you are able to answer the question. So try to be brief as possible, but also thorough. And if it gets a little bit too long, I might give you a little bit of gesture, like say, you got 1 minute or something like that, so that we can move it forward. Also, the webinar is being recorded and will be available after this event. And we are going to keep this at 90 minutes, and that will be our goal. So let's go on and meet our panel. And our first panel member, a new member to our panel, is Representative Jen Bailey Provo. Jen Bailey Provo is a current member of the Utah House of Representatives. She was elected in 2018 to serve the constituents of House District 24 in downtown Salt Lake City. Prior to serving in elective office, Jen worked as a nonprofit executive, first with the Utah Association for Justice, advocating for Seventh Amendment rights, and later for the Utah Academy of Family Physicians, focusing on primary care, healthcare, and public health, specifically on improving healthcare outcomes for all Utahns. Welcome, Representative Provo. Thank you so much for being on our panel. We're going to start you off with an opening question. Representative Provo, how is Utah doing on the vaccine rollout? Having a little technical difficulties here, so we'll get our mic unmuted.
There we go. Somebody had to give me permission. So to to whoever let me unmute, thank you. So I really appreciate this question, because I think that there is a lot of differing opinions on how Utah has done on the vaccine rollout. There are people that are still quite angry and confused and having a hard time getting information, and it runs the gamut all the way to, pretty impressed that given the shortage that we knew was coming, that getting access to the meetings was surprisingly more to the vaccine to appointments for the vaccine was surprisingly easier than they thought it was going to be. I think that practically, given that the vaccines were prioritized for Utahns 70 and older, and that the primary mechanism for scheduling those appointments for the vaccines was online, really was a setup for a lot of problems, because it's a certainly there are tech savvy older individuals in the state, there's no question about it, but demographically, there are a lot of people who just don't have access to the internet or don't regularly use it and really struggled with navigating the portals and managing that access. And so could we, you know, our armchair Monday afternoon armchair quarterback this and say, could we have done a lot of things differently or better? Absolutely. But I have been consistently pleasantly surprised by how hard the governor's office and particularly our local health departments and our state health department have been in their dedication to making sure that problems are addressed quickly and efficiently, and that every single person truly is focused on one goal, and that is to getting as many Utahns vaccinated in the most efficient, health-focused, effective way possible. And I've been also really grateful that all of those individuals have been accessible to me, willing to answer my questions and address my concerns when they come from me or from my constituents.
Great, thank you very much. Our next panelist is Dr. Fred Adler, and he started his academic career as a pure math major at Harvard University, moving toward biology as a graduate student in applied mathematics at Cornell, and joined the faculty at the University of Utah in 1993 in a position split evenly between mathematics and biology. He has used mathematical modeling to study questions ranging from his original interest in ecology and epidemiology to include immunology and many fields of molecular and biomedical biology. Dr. Adler, your question is, what do the data show about the efficacy of the different vaccines? And can we use this to predict the future of the pandemic?
Great, thank you. Thanks for the introduction, for being part of this. The efficacy data on the vaccines is in general quite impressive. As I think Ryan will explain in more detail later, there's 2 vaccines approved in this country right now. Both of them are the mRNA vaccines, one from Pfizer, BioNTech, and the other from Moderna. And both of those have over 90% of efficacy, meaning that your chances of getting infected after getting the vaccine are less than 10% of what they are without the vaccine. And the effects are relatively quick. I won't show the graph, but roughly 2 weeks after receiving your second dose, you are essentially fully protected. Why there are some individuals who are not fully protected, we don't know, but that's true of pretty much every vaccine. The other vaccines that we're awaiting approval on, so the Johnson & Johnson vaccine and the AstraZeneca vaccine, are somewhat less effective. As we know, the Johnson & Johnson is unusual in requiring only a single dose, which is appropriate. So the efficacy is higher than certainly I expected 6 months ago. What this predicts about the future is really based on 2 challenges. One, which we just heard about, is vaccinating people. And if we can vaccinate effectively everybody, or 80 to 90% of the people, then the pandemic will be well controlled. I don't think there's any reason to think this virus is going to go extinct, no matter how well we do vaccinating. It's more difficult to control than something like smallpox. However, there is good reason to think that the very severe cases will become quite rare. The other challenge that we'll probably talk about more later is the rise of these new variants. And of particular concern is the South African variant, for which at least one of the vaccines, the AstraZeneca vaccine, is barely effective at all. And so the plan, as I understand it, is to roll out vaccines as quickly as possible, stop as many of these new variants in their tracks before they become common, and then maintain the virus at a low level. So we can't exactly predict the future of the pandemic at this point, but I think we can be quite confident that the way the vaccines are being rolled out, both in this country and around the world, that the pandemic is going to be greatly reduced, if not eliminated.
Great, thank you, Dr. Adler. Our next panelist is Dr. Sankar Swaminathan, and he has specialized expertise in the treatment of infectious diseases, He is board certified in internal medicine and infectious diseases. His main clinical focus is the diagnosis and treatment of infections in immunocompromised patients, including cancer patients and transplant recipients. He has a research program funded by the National Cancer Institute on the role of virtues in cancer into his clinical practice. Dr. Swaminathan, welcome. And your question is, how do the different vaccines work?
Yeah, hi, thank you for having me here. There are currently 2 vaccines, as you've heard, that are available in the US, the Pfizer-BioNTech vaccine and the Mrna vaccine. And these are so-called mRNA or messenger RNA vaccines. The AstraZeneca vaccine, which is being used in other parts of the world, is, as is the Janssen vaccine, are based on another virus called adenovirus. And the other one that's in development, which has also undergone significant amounts of clinical testing in humans, is the Novavax vaccine. And that is not a viral-based vaccine, but is are very small so-called nanoparticles that those are what constitute the vaccine. So the way that these different vaccines work, they all essentially ultimately do the same thing, which is they present the body with the spike protein of the coronavirus that causes COVID-19. So you can see in Dr. Luper's background there, the spikes on the coronavirus. And that protein is the key protein that allows the virus to get into your cells. So that protein has to bind to a receptor on the cells, on your cells in your nose, mouth, throat, lungs, and helps the virus get in to infect you. And all of these different vaccines, ultimately what they do is that they present your body with the spike protein so that your immune system can learn how to neutralize it. And when it does encounter the real virus, can prevent that virus from attaching to your cells and can prevent it from replicating in your body that way. So but the differences are, and I know that Ryan is going to speak about at least a couple of these vaccines, but the messenger RNA vaccines are made in a laboratory and they don't have any viral components. So they really have a small molecule called messenger RNA, which is synthesized in the laboratory. And that messenger RNA provides the information to the cell to make the spike protein. So, and that's encapsulated in essentially little fat droplets or lipid droplets. And the messenger RNA, that droplet in the vaccine gets taken up by cells in your arm. And those cells will make the spike protein because the messenger RNA gives it the information to do that. So they'll make that spike protein, present it to the cells of your immune system, and the immune system basically becomes educated in how to make antibodies and make cells that can handle the virus when it does show up. The AstraZeneca and the Janssen vaccines, rather than giving the cell messenger RNA that's ready to go to make protein, they give it some DNA that gets into your cells. That DNA gets made into messenger RNA, and the messenger RNA makes spike protein. So the end result is fundamentally the same. The Novavax vaccine has pre-made protein that is uses some other chemicals to make these small particles that are then directly injected, so that the protein's presented directly to the cells in your body. So that's a sort of a technical description of how these different vaccines work. And we can talk more about that later, I'm sure.
Great, thank you very much. And our next panelist is Dr. Ryan Looper, and Dr. Looper completed his PhD at Colorado State University and his postdoctoral studies at Harvard University. In 2007, Ryan joined the faculty at the University of Utah to begin his independent career. He has developed an integrated research program at the interface of natural product synthesis, chemical biology, and medicinal chemistry. In 2009, he was awarded a Henry Eyring Assistant Professorship to continue his research pursuits. Welcome, Dr. Looper. It's great to have you back again. And your question is, does the vaccine alter our DNA?
Well, thanks, Tom, for having me back. The last time we did this was a great success, and I was excited to have this question because I have gotten this question from many of my family members, and I think Dr. Swaminathan gave a great introduction to how to think about these vaccines and why or why not they might get into our DNA. So I've heard lots of theories around about all three types of vaccines that Dr. Swaminathan described. A, that people are injecting nanobots into us that are going to do strange things. Those are not nanobots, those are nanoparticles that have the viral protein on them, and that these new mRNA vaccines can actually get in and change our DNA and have very profound effects kind of long-term or downstream. And so the short answer to this question is no, the vaccine does not alter our DNA. And I'm going to share my screen for a minute so that I can geek out on you guys for a little bit and give a pictorial representation to Dr. Swaminathan's excellent description of these vaccines. And so what I have pictured here is the central dogma of biology. And that is essentially the information flow in the sense that DNA is the information storage, ultimately being turned into protein, which are the functional machines that do things in the cell. And the gap in between, or kind of like a thumb drive if we're thinking about computers, is this molecule called mRNA or messenger RNA that transfers the message from the DNA into protein. And so for a long time, we've understood that mRNA is the messenger and provides these instructions. And it's been very alluring to think, well, if we can just add RNA to a cell and get it to make the protein we want, that would be fantastic. We could do all sorts of really cool things. But that's been impossible until recently. And I'm going to show this next slide because I want to talk a little bit about how incredibly fortunate and lucky we were that science was at a point where we could make this mRNA technology happen when this virus hit. And so the two characters I want to bring in here are Catalin Carrico and Derek Rossi. These are essentially the scientists that gave rise to BioNTech and Mrna, along with lots of other colleagues, of course. But I think Catalin's story is the most interesting. She was an assistant professor in 1990 at the University of Pennsylvania and had this idea that she was going to use mRNA and inject it, and that would make a protein that would produce an immune response. And everybody thought she was crazy, and she did not get tenure at the University of Pennsylvania. And she's probably now going to get a Nobel Prize in chemistry in the near future.
Wow.
But so she left kind of the big research universities, but continued this research. And in 2005, made this huge discovery that impacted this field. And that is that if we change one of the bases in the mRNA from uridine to pseudouridine, that actually stops the mRNA from getting rejected by the body itself. So this mRNA, this synthetic mRNA, where we've replaced a natural uridine with a synthetic pseudouridine, is now much more stable in the human body and doesn't cause its own immune response. So that was one of these kind of punctuated discoveries that propelled this field. And then in 2007, Derek Rossi started his independent career at Harvard and was thinking about using this technology to revert normal cells into stem cells. And so he came up with a lot of clever tricks that Dr. Swaminathan alluded to in terms of how we actually stabilize this mRNA and deliver it into cells. So in the case of lipid droplets or different formulations that hold that mRNA and make it able to be used therapeutically. And so between these two discoveries, that really made this idea of, oh, we can just take mRNA and give it to a cell and it's going to produce protein kind of viable. But it's now been 20 years of research that has gone into this technology. And we were just absolutely fortunate that Moderna, for example, was ramped up, ready to produce, commercialize, and essentially looking for an mRNA to do a vaccine when the coronavirus hit. And so the beauty of this is that we can very easily make any vaccine we want for any protein we want now, which is pretty incredible. And so if I think about how the actual virus works, COVID-19 is an RNA virus, so it doesn't even have DNA or touch the DNA part of this equation. So these mRNA vaccines do nothing to DNA and cannot get turned into DNA. And the RNA from the vaccine, or from the virus, once it gets into your cell, gets translated into proteins that then reassemble to become new virus. So that's how the virus replicates.
Wow.
And so, as we alluded to, the idea is to make synthetic RNA that can come in here, make proteins in your cells, and then essentially expose your body to the spike protein, but not the whole virus. And so that's exactly what these companies did. As soon as, I think it was about 30 days after the virus was kind of discovered, we had the genome of the virus, and they could just program in which mRNA they wanted to make to generate the spike protein. And once they have this synthetic RNA, they can put it in a vaccine that then goes into your cells, makes the spike protein here that we see in red, and then your body begins to recognize that. And so this is an absolutely amazing technology. And what we've seen is two different technologies in how to stabilize mRNA. So mRNA by design is inherently unstable. The cells don't want it to be stable because you want to be responsive in these messages that you make. And so it's inherently unstable. And so we see two different technologies used to stabilize the mRNA. We see Pfizer's and BioNTech's, right, has to be stored at minus 80 degrees because the mRNA is not very stable, whereas Moderna's is at minus 20. So those are two different technologies just used to house the mRNA that make the vaccines different. But essentially, we're in an era now where we can just type out an mRNA sequence, feed it to cells, and it can produce protein. So not only for, thank God, were we rescued with COVID and our ability to make these vaccines very quickly, but I think you're going to see in the next 5 to 10 years this technology impacting lots of other diseases where protein production is a problem.
That is amazing. Thank you very much.
So sorry to take the time, but
no, that's okay. I think it was very good
story.
Yeah, very, very good. Okay, well, let's start with our general questions now. So Cassie, if you'll put up our first one, and we'll get to as many as we can. So if you have been fully vaccinated, can you still spread COVID? Which of our panel members would like to attempt that one?
I guess I'll say something about
Brad,
it.
go ahead.
Others may know more than I do, but we don't really know as far as I can tell. We know that the vaccines are very protective against getting moderate to severe infections, but we don't yet know whether or not you can still get a mild infection and spread COVID. My suspicion is the spread will be greatly reduced, but I personally have not seen data, but maybe one of the other panelists has.
Well, so if you're fully vaccinated, you're still going to have to wear a mask. Is that right?
I think yes in the short run. as we're further controlling this pandemic, and hopefully in the longer run, as the number of cases goes down greatly, then we will not need to be sort of doubly protected with vaccines and masks.
Okay.
So
Yeah,
I'd like to make a comment about that.
Yeah.
So, this is a very important question. And as Fred has said, I don't think we know the full answer to that. But I think it's unlikely that any vaccine completely would prevent infection. If you had such a vaccine, it's called something that provides sterilizing immunity. And I don't think that these vaccines provide sterilizing immunity. In fact, we know that they really don't, at least at 100%, because people who have been vaccinated have been subsequently infected. And we certainly know that people who have gotten COVID can get it again. The question is, how likely are you to spread it if you get infected? And I'm hopeful. There is some preliminary data from Israel, which hasn't been peer-reviewed and published, and they've vaccinated, I think, something like 75% of their population, that there are people who have been infected after vaccination, but the claim is that they don't have as much virus replicating in their nose and throat and so on. So if that's the case, they would be less likely to be able to transmit it, which would be great. That, the vaccine would not only prevent disease, but also decrease transmission. But I think there's a couple of other things that we at least have to keep in mind, is that there are at least two types of variants that are circulating. One, the strain that's highly prevalent in the UK, in England, is more transmissible and may be shed for longer. And while we think that the vaccines are protective against that, it again may allow for people to get infected and spread it, even though they're not getting sick, because that virus is clearly more transmissible. The other one, which is not widely circulating in the US, is one, or similar ones in South Africa and Brazil, clearly can escape the vaccines that we currently have. And I think you have to consider the fact that those strains are going to be here, either imported or homegrown in the US. And they can certainly, if you have escape variants, they can infect people who have either had the strain of COVID that we have now or have been vaccinated with our current vaccines. So, while getting vaccinated, I know, makes a lot of healthcare workers feel a little bit more comfortable, we're not taking our masks off in the hospital or at the grocery store anytime soon.
That's very interesting to know. Thank you. Okay, let's go to the next question. Jen, I think this is for you. Can you be outside the restricted age bracket, currently age 70 plus, and still get the vaccine?
So if you're a healthcare worker, yes. I think that broadly across the state, most healthcare workers who wanted to be vaccinated have been vaccinated. Right now, the date is set for March 1st that 65 and over will be able to get vaccinated. We're seeing that in the vaccine rollout, there are some areas where the demand is becoming what they call squishy. So it's not as high as they thought it would be. Fortunately, they've been really responsive in moving doses from the in areas with anticipated high demand where that demand didn't necessarily play out to be as high as it was going to be. One of the things that we've discovered is, for example, In Utah County, they anticipated a certain demand based on demographics, age demographics, and the demand wasn't quite as high as they thought it would be. And it turns out it's because there are a lot of older adults in Utah County who moved to St. George for the winter. And it wasn't that the demand wasn't there, they just had the demographics placing those people in Utah County versus Washington County in southern Utah. I also want to add, because it didn't come up, in addition to serving in the legislature, I am a PhD student in public health at the University of Utah. And so going back to the previous question briefly about, whether or not if you're vaccinated, can you assume you're good and we can finally stop wearing masks? And I would say it goes back to, any other disease, we achieve a certain amount of herd immunity, but the reason we get vaccinated, even if we're low risk, is that there are people, 90% is 90%. That means 10% of people who are vaccinated probably aren't as immune to the illness as we thought they would be. And so I think that the mask wearing certainly needs to be something that we just accept for longer term than we wish it would be.
Jim, let me play devil's advocate just a little bit with
Sure.
you here. I'm 40 years old and the current age is 70 plus. Can I beat the system and hop in and still get a vaccine early?
It certainly has happened. And also on March 1st, the vaccine access will open up to people with certain pre-existing medical conditions. And one of my questions to the governor just this morning actually was, how do we screen for people who actually have those? Because the logistics of making sure everybody, what do? Go to the doctor and get your note that you have X pre-existing condition. That just delays things. And right now it really will be on your honor. And we know that people will game the system. And there's a very, maybe I shouldn't be putting this out there, and we're hoping that people will listen to their better angels and not game the system. But when you're weighing the pros and cons to that, if you're looking at the option being preventing all of the bad actors from gaming the system and jumping the line to get their vaccine versus the negative fallout that would come by making people jump through too many hoops, the risk reward analysis just indicates that we have to trust that people are going to do the right thing. And I hope that everybody does. I'm somewhere in my 40s and healthy, and I will be at the very end of the list to get my vaccine. And I hope that works out. But that also means that my 75-year-old mother-in-law with significant pre-existing conditions has now been vaccinated. And I think that by and large, most people in the state have recognized that there really needs to be, we all just have to make the best decisions. But right now, until we see broad, widespread people really abusing the system and taking advantage of those vulnerabilities in the infrastructure, then I think that we'll just proceed as planned.
So you do not want, so just to review, you do not want people that are like 40 or 50 to try to go in there because it's not their turn.
Right.
But what about the idea of all these vaccines not getting used and being wasted? Is that a problem too?
It's actually not happening. The vaccines there are very, very isolated incidences where there are extra vaccines. And when those are identified, they are being moved quickly. There are not vaccines being left on shelves right now. They're doing their best. And, there was this idea that if you gave someone their first vaccine, that you had to, no matter what, you had to stockpile that second one. But we're trusting that the numbers and the logistics coming from the federal government will continue to play out as they've been predicted. And so instead of holding a second dose for a person, we're getting more people their first dose because we are very confident that second dose is coming. And that has led to actually really pretty decent implementation and distribution of those first vaccines. There is not, you hear an isolated incident where a hospital in Utah County is like, please come get the vaccine. You have to come and get it before it's expired. That's actually not, that is definitely a very small percentage of what is actually happening. And the people that are in charge of these are acting very nimbly in moving those vaccines when it does look like there's going to be not as high a demand. Like I said before, in Utah County, the demand wasn't as high just because they anticipated a certain population over 70 would be in Utah County, but there weren't as many there as they anticipated. So they moved them.
Okay, but let me ask you this though: are we going to get a rollout to like pharmacies and others so that it can be more distributed, or
Yes.
are we allocated to how much we can get and we can't get all of it, or where does that stand?
So we are getting everything that we're allocating, and the Biden administration is telling us pretty accurately when those doses are going to be increasing. I think that starting next week, we'll get another 4,000 doses over and above what we have been getting. And so they've been planning rollout based on those anticipated incoming doses of vaccines. So, you know, I think, and yes, to the answer to your earlier question, those will be going to some pharmacies, particularly those that were identified by the federal government, CVS, Walgreens, I believe some of the national chains. And I've heard some that will even be going to Smith's as well. But they're all dependent on setting up appointments with pre-screening questions of, do you qualify? And so right now the question is, are you 70 and over? And starting March 1st, it will be, are you 65 and older, or do you have this list of something on this list of pre-existing conditions?
All right, very good. But you can say that Utah is, just because we're a smaller state than say a Pennsylvania or New York, we're still getting our fair share. They're not really, you know, ignoring us, but do we have to fight for it? Or, I mean, because we're a smaller state, or what? What's the issue
Well, I think fair share is in the eye of the beholder, but I will say that from the beginning of the vaccine rollout to now, we have gone from, I think, 40th to 5th in the state for timeliness on distributing the vaccine doses. And so we're definitely, we're building the airplane in the air. And like I said at the beginning of the webinar, we're not doing everything perfect, and there is no way to anticipate or to tell that we're going to do everything perfectly. And certainly there's blame to pass around, and there are faults that have happened. But I think that, you know, it's easy to sit back and judge other decisions in hindsight, but this is an extremely difficult process. And I hope that we can all focus on where we've got the successes, and we really have, as a state, I think we've learned quickly and have adapted in meaningful ways. And some states are actually modeling what we're doing in some of these.
That's very good. So on a grade level, what would you give Utah? A, B, C? What would you give us?
Starting when? Starting with the vaccine rollout, I would say we're a solid B+.
Okay, good. All right.
So,
well,
you know, I'd like to second this. If you look at the percentage of vaccines that have been administered by state, Utah is like 90% of the vaccine that we got has been distributed in a timely fashion. So we're doing better than 46 states, okay? But if you look at the percentage of our population that's been vaccinated, we're way down there. We're below the national average.
Yeah,
and what that tells
7%.
you is that, no, we have not got our fair share. That's not an opinion, that's a numerical fact.
Okay. So
we need more vaccines. We've shown that we can get them into people.
So that's something
that's true. We're at 7%.
We need to lobby, right? We need to show what our statistics are and say, hey, we're going to use it up. Okay. All right, let's move on. Next question. Are the different strains of COVID going to lead to new pandemics? I think we've kind of answered this, but really briefly, does anybody want to weigh
in? Sure. I think these different strains of COVID we're going to see over and over and over again. And the hope is that as our vaccine technology progresses over the years, this is going to become a situation that's exactly like the flu, right? In the sense that there is a reservoir for this, and the virus is going to come and go, and it's going to come and go in different forms. And perhaps on an annual basis, we'll have to choose what the dominant strain of COVID-19 is that year and formulate and deploy vaccines just like we do with the flu vaccine. And you know, these variants are a natural thing. I just saw a question in the chat about recombination events or crosses between two different mutants of the virus. Those things are going to happen, and they may happen in humans and they may happen in animals and come back, but they're always going to be there. I think the exciting thing is, for example, from this mRNA technology, you know, Moderna already has in phase 1 clinical trials a new vaccine for this South Africa variant. So we can dial these up pretty quickly when it happens. And I think once we're through this first rollout and have everybody with kind of a baseline percentage of protection, these won't become pandemics, but they will be like bad flu season versus good flu season.
Right. So we're just going to be back to the flu. All right, let's move on. Next question. Is COVID-19 virus ever going to be eradicated then? And the answer is probably no, right? We will have this for the rest of our human existence. Is that fair statement?
Yeah, I mean, we don't know that for sure. And we don't know if, I mean, without sterilizing immunity, it's doubtful that we're going to eradicate that, but we don't know that for sure. I think very interesting to me are these examples like New Zealand, where you have an island that's completely shut down and you keep getting, you know, small reoccurrences of COVID-19. And the question is, where did that come from? Did that come from humans and travel, or did that come from the animal human reservoir that we would be afraid of? And so I think, given that there is likely going to be a human animal reservoir, it probably will not be eradicated.
Sankar, do you agree with that?
Well, I mean, I don't think that we're going to stop seeing emerging viral infections. There's some very interesting things about viruses that come from bats that if we have time after we've gone through people's questions, we can talk about, which I think Dr. Looper is correct that, you know, there's going to be if it's not COVID-19, it's going to be something else. Experts have been warning us about influenza strains coming from birds for a long time. And luckily it hasn't happened yet, but I think it certainly could. As to what's going to happen with this particular virus, I think, you know, almost everything I said early on in this pandemic has turned out to be wrong. So I'm probably going to be wrong again. But I don't think that the situation is quite analogous to flu, which is a good thing, because the influenza virus has a much greater ability to recombine among strains and generate new variants, so that even if you had very good immunity to last year's strain, a massive shift in that virus can lead to a very widespread lack of immunity. I think because the spike protein is so essential for this virus, you know, it is going to be a race between our vaccine and the viral ability to evolve. But I think that, you know, we may get very long-lasting immunity from the vaccine, for example. We may get good cross protection so that the need for yearly vaccines may not be as necessary as it is with flu. So I'm optimistic that even if it's not going to be eradicated, it could end up being much more manageable.
And that's kind of where our goal is.
Short term, we're going to have a real problem with variant strains arising.
Okay, great. Fred, do you want to weigh in that real quickly? Just one comment?
Yeah, just briefly. Yeah, no, those are all great points. Yeah, just briefly, I mean, this virus is interesting among the RNA viruses in that it mutates and evolves more slowly. It doesn't have a high mutation rate compared to some of the other common cold viruses. And I was really struck by how little important evolution we saw before December. And I think that now that more and more people have been infected, that the viruses have something to overcome, which was immunity at that point and going to be vaccines now. And we will see more of these escape mutants, and this race with the new technologies that people have just explained is going to be more exciting. But I think, yeah, I think we're not going to win this one outright, but I think things are going to look a lot better in the long run.
Very good. All right, let's move on. Can you describe the timeline of the rate of protection after vaccination? Who wants to take that one?
Sure, I'll say something about at least the mRNA vaccines that are in use here. Is, you know, from what we know and what studies that were published at the time of the approval of the vaccines, it's quite abrupt, right? That is, you know, 2 weeks after even the first dose, but certainly 2 weeks after the second dose, it basically goes from, you know, you're fully susceptible, just like somebody who hasn't been vaccinated, to your 10% is susceptible. So the timeline is quite quick. It doesn't seem like the effect builds up slowly. It turns on, which makes sense with what Dr. Swaminathan explained about how the immune system reacts to these things. When the immune system turns on, it means business.
Okay, anybody else want to weigh in really quickly? All right, we'll move on. What do we know about the possibility of reinfection once someone has had COVID already after they had the vaccine? I think we kind of answered that. Anybody else want to make a comment?
Yeah, let me say something brief about reinfection. This has been a concern since the beginning, and it's actually rather hard to assess because we don't know how many people were infected due to the asymptomatic infections, particularly in the early phase. The figures I've seen, and I don't know if others have seen more specific ones, are there's about an 80% reduction in the infection rate in somebody who has been infected, but we don't know how long that'll last, right? That's known up for a few months, and after that, we don't know.
Okay,
So,
Ryan.
you know, I'd like to.
Yeah, oh, sorry, Sankar, go ahead, please.
Okay.
Go ahead, Sankar.
Yeah, thanks.
No,
So,
yeah, yeah, go ahead.
you know, this is very difficult, and while I'm not a mathematician, the problem with assessing the likelihood of reinfection is that it's directly tied to how much transmission is going on in the community, right? If you're in the let's say you're in the NBA and you're in a bubble, okay, and you're not going outside of that bubble, there's no transmission going on. You're all locked up, you've all been tested, you're all negative. Now, your possibility of reinfection obviously is virtually zero, and it's not because you had it before, just there's no virus circulating. So if you're in a place where a lot of people have had it or a lot of people have been vaccinated, it's going to look like the possibility of reinfection is very low because there's very little circulation. So I think we have to keep an open mind that reinfection is quite possible. And we know that it's possible once variants start emerging. So I think we don't know. And I think that even though the vaccines are really good and they probably reduce the likelihood of reinfection, the biggest risk right now, I think, is that people let up their guard too soon.
Yes, I think that's
or let down their guard, I should say. Yeah.
Yeah, very good point. All right, let's move on. How often will people have to get vaccinated then? Ryan?
I'm muted. Don't know, again, with this, this idea that, you know, this is a slower mutating virus, whether we're in a flu-like scenario or we get a little bit more, we just don't know that yet. Like we had talked about previously, you know, with the MERS virus, some of that immunity lasted up to 17, 18 years. We don't really know, and like we've been talking about, we don't know which strains will be the predominant ones once everything kind of settles. So we'll have to see, but I wouldn't be surprised if we're on the kind of annual, biannual schedule for these things.
Okay.
But
And then with all the variant mutants and all the very different viruses, it could be just like the flu shot every year, right?
In worst case scenario, it would probably be like that.
Okay, all right, let's move on. What level of participation by the public in receiving the vaccines is needed to eradicate or minimize the spread of COVID-19? Would like to take that question.
Well, I'll give the mathematician
ahead, Brad.
answer, and then you can give the reality version answer. So the mathematician's answer is, with the original strain, roughly 2.5. So each infected person would infect roughly 2.5 people. And so we have to reduce that to below 1 so that each infected person doesn't replace themselves and the population will go down. That requires removing 60% of the people from the susceptible pool. If it were the case that, say, the vaccine was 90% effective and this big unknown, whether those people are really out of play, that is, they don't get infected and they don't transmit, then 70% of people would be enough. But that's really the best case scenario, is the vaccine is effectively sterilizing, like we said, and it lasts for a long time. But with the new strains arising and the remaining uncertainties about the vaccine, I would have to say, we don't know.
You don't know.
And from a public health standpoint, generally accepted standards are about 70%. We can assume fairly effective herd immunity at about 70% immunized and effectively immunized, not in the 10% that have been vaccinated, but for whatever reason are not immune.
Okay.
Yeah, there's one thing that this isn't a medical or epidemiological, well, maybe it's an epidemiological point, but people get these numbers of 60%, 70% vaccination as, what you need. On the one hand, any level of vaccination helps to minimize the problem. So that's, going to reduce that reproduction number, that transmission metric. But even if we had 70% of the people in Utah vaccinated, the problem is that these R-naughts or RT that people talk about it's not an average thing. If you have, only 30% of a minority community or a low income community immunized, then that's not good enough. You really have to have that level of immunization or immunity well distributed throughout the population. All these sort of models are dependent on a homogeneous distribution of infection and vaccination, and that's simply not the case in real life. And it's one of the biggest problems in this country right now, is that the access to vaccination and medical care is so alarmingly unequal.
Well, I think people think that, in September or October, we're going to be able to go back to football games and go to a Jazz game and just be back to normal. Is that really going to be the case? Or are we going to have to continue to social distance? And is it more of a gradual process where we get back to what we think is normal? Because I think people are thinking, wow, as soon as June, July hits, we're going to be in pretty good shape. Is that true, panel, or no?
I have tried to tell people to get over this idea of everything going back to normal. Things are always going to be different, and we just have to accept that there's a new normal. My family and I have discussed the fact that from now on, when we have a regular common cold that isn't coronavirus, or COVID-19, because colds actually are coronaviruses. I have this discussion a lot with people as well. This is not the coronavirus, this is a coronavirus. But wearing a mask when you're feeling under the weather is something that is going to be more commonplace. When we were in Japan a couple of years ago, and there were just people that wore masks as a general courtesy. So I think that the discussion starts with get over the world going back to exactly the way it always was. That would be my 2 cents on that.
I think that's very good.
And
Anybody else want to weigh in on that, Ryan? Yeah, go ahead, Sankar. Yes, please.
I think what you said about a gradual return is probably the most realistic. So I think that,
Okay.
you know, we have to be flexible. I mean, I think if you get to a, you know, that level of herd immunity and, you know, you would be able to do certain things. You wouldn't have a party with 50 people in your house, but you might, you know, be able to have gatherings that we really don't think are safe right now with, you know, elderly relatives and things like that. We might be able to have some, you know, spectator events that are essentially not happening now. But I think the idea that, you know, we just need to flip a switch and we can only keep this up for so long
Yeah.
is as unrealistic as saying, well, you know, I'm tired of wearing seatbelts. We just can't keep wearing seatbelts for the rest of our life.
That is such a good point. That is really a good point. Thank you. Let's move on. If I'm 65 or over and receive my vaccine, how safe does it go to see my 89-year-old unvaccinated mother or any other unvaccinated person for that matter? Am I at risk of infecting someone? And I think we've kind of answered this, but let's just kind of summarize it. Ryan, go ahead. You're shaking like your head like you know how to answer this. Go ahead.
Well, we've kind of addressed this before in the sense that it's slightly unknown, and it being unknown, we should err on the side of caution. But it is known that even people who are vaccinated can have live virus in their nose and throat and mouth. And so from that fact, I would have to be concerned that I would still be able to spread the virus to an unvaccinated person, even if I have been vaccinated.
So the prudent thing to do would be go over, see the 89-year-old mother, but have a mask on and be 6 feet, right? Okay. All right. All right. Let's move on. Next question. Are there any long-term effects from the vaccine? Sankar, do you want to answer this one?
So the answer to that is I would be lying if I told you no, because no one knows the answer to that question. That's the honest truth, but that's true of any vaccine. That's true of any drug that's only been out for 6 months.
Right.
Because we have had drugs that were tested in lots of people, and then after 4 years, we found out that, you know, 1 in a couple of million people had some side effects or long-term effects that only showed up after a long time. But the fact is, scientifically, there's no reason to think that there would be long-term effects from the vaccine other than immunity, because the principle is the same. You essentially introduce a foreign protein into your body and to teach your body how to respond to the actual virus when it shows up. So, I can't say no because you never know, but there's nothing intrinsically different about what this vaccine does that would make me think that there would be any long-term effects. Because in general, vaccines are one of the things, aside from, having clean water and, safe food and air, that have saved millions and millions of lives, especially lives of children. So the long-term effects of the vaccine are to reduce death and disability. Those are the real long-term effects from the vaccine.
Okay, very good. All right, let's move on.
Well said.
Is Utah reaching groups hardest hit by COVID, such as the Navajo Nation? Jen, are we hitting the Navajo Nation?
So my understanding is, yes, we are doing a better job at reaching some of our marginalized communities. And Dr. Swaminathan was absolutely right. We have marginalized communities who have been devastatingly hit in our state. One of my colleagues, Representative Kwan, represents Taylorsville, got a statistic just recently that in her district, 95% of her Pacific Islander community have had COVID. 95%. I mean, that's breathtaking. I can't even begin to wrap my head around that. But also recognizing that within our minority communities, there's a lot of distrust in our scientific fields. And so in addition to just difficulties in getting the vaccine to communities that have been traditionally hard to reach, there is a very valid fear and trust of the system that is trying to get the vaccine to some of our marginalized communities in the state. And so even if we are exceeding efforts in some of our marginalized communities, I would say that no matter what it is, we aren't doing enough and we've got a lot of work to do.
All right, thank you. Let's move on. Should we be wearing 2 masks? How long will be masking in public? Now we've kind of answered that question, but I've also heard that if you have like a cloth mask, something that's been made for you or something you buy, that it's good to wear a surgical mask and then put the cloth mask over the surgical mask. Is that true, or is that a wives' tale, or what's the issue on 2 masks?
So do you want me to?
Yeah, go ahead, Sincarf. Go ahead.
So there are 2 important factors with masks. One is, what's it made of and how well does it filter? Okay, so on one end of the spectrum, you have just a bandana type thing, a cloth that you can see through that does almost no filtering. And on the other end, you have the material that surgical masks are made of, and also N95 masks, which are very impervious to passage of small particles, okay? But even if you have a mask made out of good filtering material, it essentially does very little if it leaks. Yes. Okay, so if you take a surgical mask and you put it on, one of the problems with a surgical mask is that if you breathe, you can feel the air going in and out on the side of your face. Yes. Okay, so while that still does a lot to prevent particles from being expelled and hitting the person you're talking to, it actually doesn't prevent you expelling them into the room. And it also doesn't prevent you inhaling them through those gaps in your mask. So if you have a surgical mask, which is good filtration, and you put a cloth mask over it, that kind of seals it to your face. It does what the big thing about the N95, they're fitted to us and they fit very tightly and there's essentially no leakage. And you can get a lot of that by using a second mask that ensures a tight fit. And the other thing, of course, that 2 masks do is that they improve the filtration of what may be a substandard cloth mask if you have a a surgical mask.
So you're recommending that you put the surgical mask first and then the cloth mask over the surgical mask so that you get a really good fit with the surgical mask. Is that right?
Yeah. Yeah.
Okay.
And so one of the suggestions that I think is on the CDC website is that you can take a sort of surgical mask. This isn't a surgical mask, but you can take a surgical mask like this, and before you put it on, you can sort of knot the ear loop so that it fits tightly here when you put it on. So there are various things that you can do to achieve a better fit, as well as getting good filtering material.
Well, now, is there a point of diminishing returns? If you can go 2, can you go 3?
Yeah, if you put a pillow over your face, you're not going to be able to breathe very well. So if your masks, get so restrictive that it makes it difficult for you to breathe, then you're obviously not going to wear it much, and it's going to be difficult. You're going to be fiddling with it and so on. So you have to strike a balance between convenience and safety.
Very good. All right, let's move on. Why isn't there a federal rollout plan for vaccine distribution, Jen?
I would say that there is a federal rollout plan for vaccine distribution. It's just still in the process of being created, and with the new administration coming in the in the middle of the vaccine rollout, they're struggling to make up for lost time, certainly. But I think that the lion's share of the philosophy is to just get vaccines to states and let states handle the process in the best way that they can in their communities. So I would say there could be better communication from the federal government on what's going on. But when it comes right down to it, if we're talking about finite resources, I would rather they just focus on getting the vaccines out instead of marketing about it.
Very good. Good point. All right, let's move on. What other vaccines are expected to be approved soon, and how do they work? So Ryan, do you want to start?
So I think we've basically covered this, that there are multiple technologies at the RNA level, the DNA level, and then also kind of this new nanotechnology level. As of right now, they don't, from what we've seen thus far, they don't work as well in terms of protection efficiency as well as the mRNA vaccines. But we don't know that that's not really a fair shake, given that some of these are being tested in a new kind of COVID landscape that wasn't the same COVID landscape as when the mRNA vaccines were tested, because they were so quick to the clinic. So I don't think we know exactly how well they work compared to each other yet. And it's going to be a while till they're out in the general public that we can really make those assessments. But I think it goes back to the question I hear a lot, which is, which vaccine should I get? And my answer would be any, because
Right.
it's not just about how well do they work in terms of
Right.
me not getting infected. It's the mortality rate is significantly lower with all of these vaccines. So it's the mortality rate that we really care about. And that, I think, is fairly consistent amongst all of them.
Fred, do you want to weigh in a little bit?
Yeah, actually, I wanted to ask Ryan a question. So earlier you talked about how the mRNA vaccines can't modify our DNA by any mechanism we know, but you didn't really discuss that for the adenovirus vaccine, which you said is DNA. Is there a risk of that having an effect on our cells?
So there is, and that actually happens naturally all the time. So we have all sorts of junk DNA in our genome that have been left from years and years of battle with viruses. But it's not clear that any of that technology would be damaging in a sense. That is to say, our bodies have very, very, very efficient ways of dealing with unrecognized DNA.
Okay, very good. Let's move
And
on.
I just want to.
Sorry.
There's a lot of fear about vaccines, and not just this one, but the fact is that I don't have concerns about I personally, as a physician and as a virologist who's been doing this for 35 years, I'm not particularly concerned about it. And the reason is that adenoviruses we get infected with every season, okay? We've all been infected with adenoviruses, and that's the framework for making the AstraZeneca and the Janssen vaccine. And so yes, while they're made of DNA, adenoviruses don't get into our DNA. Okay, they're not there, even though we get infected with them every year. Okay, and the way that these vaccines are constructed, they really don't have the ability to replicate in our cells like viruses do. So I'm no more concerned about the DNA in the vaccine than I'm concerned about the DNA in the hamburger that you eat.
Yeah. Right.
It has about as much chance of, you're getting cow DNA into your cells, as far as I'm concerned.
Correct.
Okay, great. All right, let's move on. How can we trust anyone on vaccine information? We're stumped.
Well,
How can you not?
Well,
It's not a question that stumped us.
Well, it's the problem is that it's a loaded question, right? So,
yeah.
well, I think it's a good question though, because there's a lot of distrust and skepticism and fear. But I think this question could be asked about almost anything. How can we trust anyone? Because
Right.
it used to be that when I was growing up, there was the Encyclopedia Britannica and Walter Cronkite. Okay.
Yeah.
And you knew that you could trust those sources. And this is what President Obama called an epistemic crisis. And what that means is, how do you know when something is true? If you don't agree on what constitutes, fact, then you have a crisis. And I think we have a crisis in many ways in this country. So I would say that, the internet is an extremely unreliable source of information, because it's like walking into a bar where you don't know anybody and you just, are listening to this guy sitting on a stool spouting off. That's what the internet is. It's about as reliable as doing that. Okay.
Right.
So unless you know that the guy sitting on that bar stool is a physician or a chemist or a scientist or a virologist, then, you can't trust them. Okay. But I think that if you have to look at the source, and at some point you have to believe that, doctors and epidemiologists and people who actually have spent their life studying and learning and teaching about this actually do know what they're talking about. Because otherwise, I think you're sort of in a place where you can't really know anything.
Right. I think that's very good. And that's the purpose of this webinar, is
Correct. And
how it got formed. We want to try to give correct information to people so that they can make intelligent decisions. Because when they don't have good information, they can't make good decisions. And so our goal is to give them good information. Somebody was speaking. Was it you, Jen? Did you want to say something?
I was going to say, just real quick, I draw a very similar analogy to the therapeutics aspect of this. And we talk a lot about the fear and distrust, or, what's going to happen, is the vaccine safe, et cetera, et cetera. Well, I'm a lot more scared of not having the vaccine than I am of having the vaccine.
Right.
Because of what it can do for me and what it can do for my community. And I think the same is true of information. I'm much more scared of not having information than I am of having information, but we have to make sure the source is somewhat reliable, which is where I go back to Sankar's points.
So Fred,
Can I
is the
add one thing?
CDC reliable? Oh,
Sorry.
excuse me, Jen, go ahead.
I just wanted to add one thing really quickly. I think one of the things that we're not talking a lot about when the question comes up of whether to vaccinate or not vaccinate goes back to this notion that was really pervasive before the vaccine, where people were thinking, oh, I just want to hurry up and get coronavirus so that I can get immunity and I can get over it, because it's not, most people I know don't get that sick. But I hope that I'm proven wrong on this, but I'm really concerned that for 20, 30, 40, 50 years, our health system is going to be really overburdened with health, chronic health problems that are associated with having contracted COVID, because it is we're finding out that it's a vascular disease, not just an airway disease. Lesions on livers, kidneys, brains, lungs. And so, I think that when I have this conversation with people about how do we trust the vaccine, I think it's important to pivot back to that conversation, is how can you trust that you're not going to have health problems for the rest of your life because we're cavalier about getting coronavirus.
All right, so panel, let me ask you just a minute. Panel, let me ask you the question then. So I'm coming here as a citizen. What is my source of information that I can count on? Is that just the CDC only, or where do I go?
I think we have to look at the CDC now as a source of, correct information. So it would start there, but that information isn't always as detailed as we'd like. Those are very broad strokes and broad guidelines that those federal agencies give out. And I think you do have to filter down to community forums like this, like trusted people in the community to get information from for specifics that affect your community.
All right.
I
very
would
good.
say that, while every physician isn't necessarily an infectious disease expert or an expert on COVID, I think one of the most reliable sources of information for the average person, because they need specific information, as Ryan said, just going to the CDC may not answer your question. There are many, I was looking at the chat, there are many outstanding questions here that I'm not sure that we will get a chance to answer. Some of them are very specific, but I think those are the kinds of things that your physician or your nurse practitioner or your healthcare provider can really help you with, because they can tailor that knowledge that they have and to fit your specific situation. And I think that, you can trust those people. I mean, that's what they're there for.
Okay, Fred, you
Here.
wanted to say something, I think.
Yeah. I mean, I'd say two things. The internet is a double-edged sword, but we have more access to information now than we ever had. And so, for example, if I want to look up the detailed data on the efficacy of the vaccine, I can find it now. And I think the key really is the distinction between a healthy skepticism and an unhealthy skepticism. Healthy skepticism is what science is built on, right? There are no known facts. Everything is only based on the data we have available. And I think we should always realize the limitations of our knowledge. Unhealthy skepticism is what I think is this epistemic crisis that we see, that people distrust things because they're said by experts, not because they don't trust the evidence. So I think that our challenge as citizens, and myself as an educator, is critical thinking and to encourage a healthy skepticism. The CDC has been wrong about things. That's fine. They've been open about that. We should be appropriately skeptical and look for further information if we have doubts.
All right, very good. Let's move on. We're getting down to the kind of final of our program, so we're going to try to move a little quicker. Can the 2 required doses come from different manufacturers? Brian, real quick. No. Okay. So I think that's all we need there. Next question. What, if any, are the long-term effects of the vaccine? I think we've answered that, right?
Immunity.
Hopefully immunity.
Right.
So, but I do want to say, that's why I said before, I'd be lying if I said that there are none. I mean, I can't say that because we've only used them for 6 months. And I don't expect you to, trust everything I say because I have credentials. But I think that, if you were to come or be seen by me in the hospital, or we are on a discussion like this, that, that I can actually support, you should look to see whether, this person can answer your questions in a way that you believe.
Yeah.
And, we've all been wrong about this virus before because our information, was sketchy at the beginning, and it still has gaps in it.
And we're still learning, sure. All
And
right,
likewise, I'd like to go back real quick and say, I wasn't being glib with just saying no to the 2 vaccines.
Yeah, let's go back to that other question because I felt bad.
But again, it's because we just don't know, right? So we only know what we know. We don't know what we don't know. And the only thing we know because of clinical trials are 2 subsequent doses of the same manufacturer. So yes, chances are that multiple manufacturers' vaccines, if given in willy-nilly ways, will probably give you a fair amount of immunity, but we don't know that.
Okay.
And so,
and Ryan, why are 2 doses required and not 1?
So it appears to just be the level of response that the body has to the amount of protein that's produced by the mRNA vaccines.
So is Johnson & Johnson's 1 dose realistic, or are they going to be?
Yeah, it could be realistic because it's a different type of vaccine. So the J&J vaccine is a traditional vaccine, and it could produce a sufficient immune response with 1 dose.
Okay, very good.
There
All right,
is a
let's
lot
move
of-
on.
There is
Yeah.
a lot of evidence with a lot of vaccines that a second dose essentially provides more durable immunity,
Correct.
Okay.
better immunity. And because the trials were done with 2 doses, we really don't know how much that improves it. We think it does improve it, and it may provide a longer lasting immunity. But as Ryan said, we don't know what we don't know. What we know is that this was designed to be given as 2 doses spaced about 3 or 4 weeks apart.
All right,
They
let's
could have
move on.
equally as run the trials with 1.5 doses, 2.5 weeks apart, right? And they could go back and do that, but that's not how they did it. And we only know what they did, and that's what we know. So
All right, let's move on. We've got a lot of questions still to answer, not much time. Are variants of a virus normal, like we are seeing with COVID-19? How do the vaccines help protect against these variants? Fred, you want to?
Yeah, we've discussed this a lot. I mean, to some extent, we don't know, but we do know that at least some of the variants do escape the vaccines, and it seems likely, or there is evidence that the South African variant escapes to some extent all of the vaccines. Yeah, it's normal, right? Viruses mutate.
We're not going to have a perfect system. Okay, let's move on. Next question. How long is the vaccine in the body? Sankar, how long is it in the body?
The messenger RNA is probably there for at most a few days. Everything gets degraded at a certain rate. So for it to be completely eliminated, I think the evidence is a few days. The DNA-based vaccines, perhaps a little bit longer, but they're particularly long. And I want to come back to this because I think it speaks to the fear that a lot of people have. And if you think about it, if you get infected with the virus, okay, you're getting billions, literally billions of copies of viral RNA all through your body. Okay, this is a minuscule amount of mRNA or protein or DNA that's injected in your arm. It pales in comparison to what actually happens when you get infected.
Okay, very good. All right, let's move on. How has Utah's economy been affected by COVID, Jen?
So I think everybody's pretty well aware of how the shutdown in the spring really impacted a lot of communities and businesses and employees in the state of Utah. And in anticipation of a huge downturn, the legislature convened several special sessions this last year to make some very significant budget changes after last year's session. It actually has turned out to be not as bad as we anticipated. Utah has fared better than most states in the country, so much so that we are sitting on right now in the middle of session about $1 billion in one-time budget surplus funding. And that's positive. It's great to be able to report that, but I think it's a mistake to hang our hat on that because there still are a lot of people and a lot of families that are hurting very, very badly financially in the pandemic and have not yet recovered and may take many years to recover fully from, as far as vulnerabilities in housing and employment. And so, is comparing ourselves to the rest of the country the right bar to be measuring it by? Sometimes I question that. Just because we're doing better than a bad outcome does not necessarily mean we have a good outcome economically, but we know that I can say without hesitation, we have a lot of work to do before we are back to where we were before the pandemic hit.
Okay, next question. Do we know how much protection the vaccine gives different age groups? When will a vaccine be available for children?
So hopefully soon. The clinical trials in children are going on right now. I don't know exactly when that's supposed to be wrapped up, but I would imagine in the next month or two, we'll have a preliminary release of guidance on how far down the age bracket we can go with vaccines.
Okay, and so is there a different protection level with different age groups?
We will not know until the results of those clinical trials are released.
Okay, next
One thing I
question.
would say though is
Go
that
ahead.
the
Thanks, Mark.
vaccine
Go ahead.
trials, the vaccine trials with Pfizer and Moderna, which are the ones that are currently available, were remarkably effective in the elderly. I mean, there's been almost no vaccines that are as effective in extremely advanced age people as these vaccines. The only other exception I would say is perhaps the shingles vaccine, which is also extremely effective in quite old people. But you know, if anything makes me happy about this, it's that these vaccines were so effective in people as old as 80 plus. And it may be, and I hope it is, it may be due to the fact that an mRNA vaccine is a particularly good platform. And if that's the case, it might be that we're use this platform for making more and more of our vaccines going forward. And, you know, the flu vaccine, for example, is not very effective in the elderly, which is who are the ones who really need it. And so I think that's, you know, one thing that's really a positive about the development of these vaccines, besides the fact that they are making people immune.
All right, let's move on. What is the government doing to help life get back to normal? What should we be doing as a community, Jen?
So this is an interesting question in a state like Utah, when there is a lot of discussion about the proper role of government in injecting itself into everyday lives. And so as far as what the government is doing to get life back to normal, I think that by and large, we're trying to get as many resources to our departments of health to help people get vaccinated, and also getting resources to people in as many ways as possible to help with rental assistance, to prevent homelessness, increasing access to health insurance wherever possible. What we should be doing as a community, we should be looking out for each other. We should be wearing a mask. We should social distance. We should do everything we can to minimize spread. You know, it feels like the light is at the end of the tunnel because the vaccine is rolling out. But like Sanker said, we are 7% of our state right now is vaccinated. We are making progress, but we have so far to go. And the problem with good news like a vaccine is that we change our behavior, and we can't change our behavior. We have all made a lot of sacrifices to try to survive this pandemic. We can't let up now. We really have to, pull this through to the end and look out for one another, and to really reject some of this rhetoric about, the untrustworthiness of science and data. And we have to just really insist on elevating the conversation and stop with this anti-science, anti-vax rhetoric that is so harmful and really truly puts people's lives at risk.
Very well said. Let's move on. We're going to try to,
I want to add real quick, Tom, that I think what should we be doing as a community? I just want to reinforce this idea that this is going to be a gradual recovery, right? This is not going to be punctuated and we're back to normal. So as a community, I would urge patience in this getting back to normal. I mean, even at the university, as we start to think about what our class is going to look like in the fall, this is a very gradual recovery, right? We don't want to make the mistake of, come June saying, oh, 70% of people are vaccinated, we're all back to normal, and then realize that was a huge mistake. So the community, we need to be patient, and we need to follow science and the guidelines to make sure that we know what we know before we go too far.
All right, let's move on here. I think we've got just a couple minutes. Please describe what parts of the approval processes were expedited. Jen, or who would take that? Ryan, on the approval processes of the vaccine, I guess is what they're meaning.
Yeah. So a lot of people are skeptical because they've heard that the trials for the vaccine were rushed and they were conducted really fast and so on and so forth. And the reality is that that's not really true. So this went through the same process of any other drug or any other vaccine, right? Remember, the flu vaccine gets approved on an annual basis. So we do that approval in a year. The reason this was able to move so fast is because it was really easy to recruit patients, because there are a lot of people that want the vaccine or have COVID, right? I mean, if you're trying to develop a new drug for a rare disease that only affects 1 in every 10 million people, you have a hard time, and it takes a long time to conduct a clinical trial. It just turns out that the ability to get the data on these vaccines was remarkably easy, but they went through the same vetting process as any other therapeutic.
And
Well, very good.
You know, I'd
Yeah,
like to just
go ahead. Final comment?
Well, I think this is important for people to have faith in, because, as Ryan said, the fact that there was a raging pandemic meant that the trials that enrolled 40,000 people each, they were able to be completed in a much shorter period of time than even the drug companies thought it would take, because so many people got it in the placebo group, and they were able to show that the vaccine was effective very quickly.
Right.
But the FDA approval process for vaccines and biological products is similar to the ones for antibiotics, for example, or other drugs. And I'm on one of the FDA's advisory boards for antimicrobial drugs like antibiotics. And these are people like myself. There's a panel of like 20 people. Sometimes they bring in extra people to sit on this panel to provide special expertise. And they are doctors, scientists who have no connection to the government, who have no connection to the drug companies. In fact, we have to submit signed affidavits that show every possible investment or any connection we could have to any commercial interest. And these people are brought in and we're given all the data that that the drug companies generated. And we spend weeks looking at these, and then we have a meeting in Washington that's open to the public. And this is exactly what happened with each of these vaccines. You cannot imagine a more rigorous approval process than is conducted in the United States for these kinds of things. There is no other place other than perhaps in Western Europe where such a rigorous scrutiny is applied to these things that are before they're released to the public.
Very good. Well, we're out of time, everybody. I want to thank my panel. Thank you so much for your time tonight and for all your expertise. I think what I'm getting from this is, number one, from Jen's standpoint, we've got to be good citizens and not try to jump the system and wait our turn in line, because we're taking away from those people who want to need the vaccine. And then from Sankar, when we're vaccinated, we still got to wear a mask, and we still have got to realize that we have to be aware of that. And from Ryan, it's going to be a gradual period, and it's going to take some time, and we're not going to be back to normal. And Fred, I guess what you're trying to say is also the same, right? Any last thoughts from you, Fred, on summarizing something for the panel?
Yeah, I guess it's mainly the point about, trusting the experts, which is really being an active citizen. It's up to you to look curious.
Trust but verify.
Exactly.
Right. Exactly. Well, thank you, everyone. And we appreciate all of your help. And thanks, everyone who attended. Please be aware that this will be recorded. So if you missed something, you can listen to it again. I want to thank the College of Science. Intuitive Funding has a wonderful relationship with the University of Utah's College of Science. I want to thank Cassie Slattery for her great work on the board tonight, and Vivian for her help, Jeff Martin, and the Dean, Peter Trappa. What a great group. I just love working with all of them, Peter. They're really great. And I will turn the final words over to you.
Hey, can I jump in real quick before you speak?
Bet.
This chat feature that we've done on here tonight was one that we didn't see in the last session, and there are some phenomenal questions in here. I was wondering if Cassie might have a way that we might be able to capture these, because I would be willing to take some time to respond to these offline, and if they could be accessed through the College of Science website, like responses to these questions that people who ask them can go to look at them, that would be fantastic. So, because I feel really bad that we didn't get a chance to get to all these questions.
There's some
I do
really
too.
great questions on there.
Yes.
Yeah,
I
I
do too.
agree. And we'll be able to put the recording. Cassie, are we going to put that on our College of Science YouTube channel? And we'll also have the opportunity to put some of these supplementary materials, these answers to these great questions that have come in through the chat on the College of Science YouTube channel. So it should be easy for people to access there. And I just wanted to echo Tom's words of thanks to our fantastic panelists and thank all of our attendees for engaging in this really important conversation. And I hope that this is one of many that we'll have over the course of the months and years ahead that we have through this forum and through this partnership with Intuitive Funding. So thank you, all of you. Thank all our panelists and thank all the attendees. And I hope you have a good evening. And if you haven't shoveled out, you might have a lot of work tomorrow morning.
And
you.
be safe. Wear your mask. Take precautions. And just
Be
because
kind
you're
and
vaccinated,
courteous.
you're not Superman, even though you've been vaccinated.
Thank
Good night,
you.
everyone. See ya.
Honor to be here.